Everyone, welcome to topic 4.1, Introduction for Reactions. At the end of this, you should be able to identify evidence of the chemical and physical changes in matter. You should understand that matter is material that occupies space and contains mass, so it has volume and mass, and it can be organized in many ways and undergo physical and chemical changes. We have this organizational chart to help us structure it into the different types of matter that we might encounter. We have homogeneous mixtures, where it's a combination of two or more substances and you can't see separation between them. So this would be things like milk, coffee, and so forth, where you can't see a separation. Heterogeneous mixtures, you do see the separation. So two or more substances and you see it. This would be like a bowl of cereal with milk in it. We also have pure substances that come in two forms, and this has constant composition in it, so it's only one substance in there. And that can either be a compound, which is a combination of multiple atoms and different types of atoms, all chemically bonded to each other, or elements, which is just one type of element, and it can be broken down by physical or chemical means. So, distinguishing between physical and chemical changes, you should understand that physical changes, you can change the substance without changing the composition. So it's still the same chemically, but how it is physically present has been altered. So this includes state of matter changes, as well as tearing things like cutting wood, tearing paper, those kinds of things. You aren't changing it chemically, but you are altering what it looks like physically. So dissolving salt is considered a physical change because you can get it back. This diagram to the right shows the differences in physical properties and particle arrangement between the substances in solid, liquid, and gas phases. In a solid, the particles are packed in rigid configuration, giving the substance definite shape and size, and as you reduce the intermolecular force attraction, so you go to a liquid, they're close together, but they move a little bit more, so they have definite volume, but indefinite shape. And then as you further decrease the intermolecular forces and move to a gas phase, they do not interact at all, and so they have indefinite volume and indefinite shape as they fill to take the entire space of the container they are in. The phase changes are shown here. Okay, and so as you increase the enthalpy or energy, heat energy in the system, you change your state of matter. And then we have different words for each of the states of matter, so you should be familiar with those. Okay. Other examples of physical changes include the separation of mixtures. This can be achieved through distillation, which separates substances based on differences in boiling points, filtration, which separates substances based off of particle size, or chromatography, which uses differences in intermolecular forces to separate substances. Other types of physical change are deformation of the substance. This can be through cutting, denting, tearing, stretching, and so forth. Making solutions is another type. So we have deformation, we have making solutions. The key feature of physical change is that the atoms are not rearranged. The physical properties, shape, color, texture, flexibility, density, mass, and so forth are changed, but it is not changed chemically. Physical changes are usually reversible. And so we have additional pictures showing a solid, liquid, and gas representation of water. When we look at chemical changes, the property of a substance changes. We have breaking of bonds and the formation of new bonds. So something new, chemically new, is made. We have some evidence of that, including production of a precipitate, color change, light, change in temperature, sound being made, so like an explosion, evolution and production of a gas, and formation of a new substance with new properties. Okay, these are usually very difficult to reverse. And then we have our basic types, including composition or synthesis, decomposition, single replacement, double replacement. This includes acid-base reactions and precipitation reactions. And then combustion, which includes both the hydrocarbon and a metal. All of these are redox reactions, which we'll get into later in this unit, except for the double ionic replacement, because the ionic charges don't change. And so we'll look at that further later. Okay, so we're going to look at the IDs and WEDs now. So working these out, we want to use these images to describe the type of matter, so from earlier in the notes, and the states of matter that are present. So here we have types of matter. So we see two atoms that are the same bonded to each other. So we could say compound, but this is definitely a pure substance. And because this pure substance, the two atoms look the same, I'm going to say it is an element, because it also looks like it is a gas. And so this is probably a diatomic element, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, or iodine, one of those, and they always come in pairs. Because there is a random arrangement, I'm going to also say that this is a gas. Okay. Looking at the next one, we see that we have two different compounds here and here. And so that means that we have a mixture. And it looks like it is uniform, so spread out. So we have a mixture. I'm going to say that we have a homogeneous mixture. Because we have two, and it's we can, in the particle one, pick out the different ones, but we can also assume that this is just randomly spread out. Okay, these are pretty close together and look like they have a pretty regular arrangement, so I would say that these are, a liquid. I would also accept gas on this because this is not a big enough particle, but I would say liquid because these are a lot closer than in the first image. Moving to the next one, we see we have a compound and an element. So again, we have a mixture, and I would say a homogeneous mixture again. Though heterogeneous would work because we don't know how these are arranged at the large scale. We can also say, due to a slightly regular arrangement and close orientation, that this is probably a liquid, though you could also say gas for these. Looking at the next one, we see we have a compound. So a pure substance, and it is a compound because we don't have anything else besides the blue and the orange combination. And we can say that this is probably a gas. Looking at the next one, we see we only have the blue circles, and so that would be an element, which is a pure substance. And then moving down, we have a very regular arrangement, and it is not filling the container, so we can say that this is a solid. And then looking above at the next one, we have two different ones, so we have probably a homogeneous mixture, and that this is probably a gas, though again, without more space and relative comparisons, we can't say more than just gas or liquid as well as homogeneous. Okay, scrolling down. Looking at our we do. For each of the following examples, decide if a chemical or physical change has taken place. Over time, solutions of iodine and water gradually lose color as the iodine evaporates. So our key word here is evaporate. And if we look back in the notes, we see that that is an indication of a phase change from a liquid to a gas. And so since that is a phase change, it is a physical change. And so this would be physical. For the next one, when a drop of acid landed on the chemistry teacher's pants, a small hole appeared. This has happened to me quite often. Acid wear on denim in general is a chemical change because we cannot get the denim back. A small hole appeared. The acid has changed the chemical composition of the denim, or the not necessarily denim, but of the pant. And so we have a chemical change because we can't get it back. And it is permanently changed. Those pants are ruined. Though also getting like marker on pants might ruin it too, but you could probably get those out with some washing. When a solution of lead 2 nitrate and a solution of sodium chloride are mixed, a cloudy white precipitate forms. If we go back in our notes to signs of a chemical reaction, we see precipitation formation is a sign of a chemical reaction. So this would be chemical. At a Halloween party, many people use dry ice, solid carbon dioxide in their decorations. It sublimes into a gas and creates a foggy effect. Sublimation is the process of changing a solid into a gas. That is a phase change, so it is a physical change. Okay. Using the notes, continue to work through the examples here. Okay, make sure you're referencing the notes though, because a lot of these are review, but may have been a hot minute before you had seen them. So thank you for tuning in, and see you in 4-2.